Okay, last part. Let's start from the put-call parity. So put-call parity is the relationship between the put premium and call premium. So it says that the call premium minus put premium equals to the current stock price minus x times exponential function of the negative all times t. So, and actually, this is a discount factor in continuous compounding. So this is same as present value of the exercise price, present value of the exercise price. So we'll see why. We'll see why. So suppose you have call option and put option. So you have the call option, buy call, and write put. That's basically same as C minus P, right? Okay, and let's find the case. Let's find the case. Okay. We have two cases. Case one, stock price is below exercise price. Case two, stock price is above exercise price, right? See what happened. So when stock price is below exercise price, call option is not exercised and put option will be exercised, right? So the put option will be exercised, but you write a put option, so you have pay the value, intrinsic value. It's basically same as T minus X, right? Right. And then if the stock price is above exercise price, then you hold the call option, you exercise it, so the value is ST minus X, and write or put, nothing, so ST minus X. So in any cases, you basically, the C minus P, the call minus put option premium equals to the present value of, because this should be present value, this is future value at T, right? So present value of ST minus present value of X, right? And present value of ST is simply today's stock price, and present value of X is X times exponential function of negative RT. So you have put call parities, put call parities. From this relation, you can actually calculate the put option value without using the formula of put option, Black-Scholes put option models. Simply put option equals to call option minus S0 plus X times expansion function of R times T, minus R times T, actually, negative R times T. So, and if there's a dividend yield, then you can simply add present value of the dividend yields. Okay. So that's how to get the option, put option value. I mean, there is not like a complicated formula actually using the put option value, but you really don't need to get it, because if it holds, then it should hold. We can actually verify using the Black-Scholes model too, actually. So this is why. Long call short put should be same as just a leveraged equity. Okay. So put call parity, let's look at this. Suppose you observe the following data for a certain stock. Stock price 110, the call price for $105.14, put premium, same thing, 6 months maturity, exercise price 105 is 5, and the risk-free rate is 5%. So if you calculate the put option, using the put call parity, C minus P equals to here 9, but S0 minus present value of exercise price is actually 7.959. What does it mean? It means that the put call parity doesn't hold, which means the valuations, there is mispricing. So you can get abnormal returns, arbitrage opportunities actually. Okay. So how to get it? So to take the arbitrage opportunity, what you have to do is, this is higher value and this is lower value, right? So the C minus P is a higher value, which may be overvalued, and S0 minus X times exponential function of negative LT is the underpriced. So you sell overpriced, short position overpriced one, so you basically have sell call, buy put, and you long these underpriced one, so you hold, you buy stock, and you borrow X times exponential function of negative LT. Okay, in this case, you have, so $14 pay, and you actually, yeah, you write a call, so you receive $14, right? So, and then you long put, so you have $5 paid, right? Because you buy call put option. And then stop price is 110, so you pay 110, you borrow X is 105 times exponential function of R is 0.05 times 0.5. So it's going to be actually 104, I believe. 102.41, I'm sorry. 102.41, that's your borrowing. So let's look at next table actually. Next table actually show it. So you buy stock, so you pay $110, you borrow this present value of exercise price, which is $102.41, and then you sell call, so you receive $14, and you buy put, you pay $5. So basically, you just, what you do is you have short position of C minus P, right? Because now you sell call and buy put, and long position of right hand side as 0 minus present value of X, right? Because this is higher, this is 9, this is 7.59. So this is overpriced, this is underpriced. You sell underpriced, the short position under overpriced one, and you buy underpriced one, long position of underpriced one. So that's what you did, and you receive $1.41 today. What you do is now you buy stock, so your stock price will be ST, and we have two cases. ST maybe below exercise price or above exercise price. If it is below exercise price, it means that, I mean, this is also same, you have to pay back $105, right? If it is below exercise price, then put option is in the money, so only put option will be exercised, and call option is not, so like this. Then you have 0. If stock price is above exercise price, then call option will be exercised, because you sell call, you have to pay this, and no payoff from put, so it's 0. So it means that you receive $1.41 today, year later, your payoff is 0. So it's actually offset each other, hedging. Your total profit is just $1.41 without taking any risk. There's no risk. Any cases you make this money, which means this is arbitrage opportunity. This is a strategy for using the put call parity. Obviously, this is too big opportunity, so you're not going to get this opportunity. But theoretically, you can use this strategy to get these opportunities. Mostly, again, arbitrage opportunity, immediately go. Okay. Black-Scholes put option valuation. This is the formula. Again, you can use this formula. We can also use Excel spreadsheet as we did for call, same thing. And you can obviously complete to get these values. Now, the final topic we're going to learn is hedge ratio. So from Black-Scholes formula, we can get actually so-called hedge ratio. And hedge ratio is the number of shares required to hedge price risk of holding one option. So if you have one option, you can hedge the price risk completely, but how many shares are required to hedge? Okay. So this hedge ratio can be calculated ND1 for call option and ND1 minus 1 for put option. That's usual case. Okay. So if you have this graph, this is the call option value graph. If the price is 120, the hedge ratio is the same as just a slope. Okay. And suppose slope is 0.6. So this is called delta 0.6. It means that number of shares 0.6 delta. So 0.6 shares required to hedge price risk of holding one option. Okay, that's what it means. So finally, using this hedge ratio, we can use the synthetic protective put strategy. So suppose a portfolio is currently valued at $100 million. Okay, and at the money put option on the portfolio might have a hedge ratio. So delta is a negative 0.6. So always put option should be negative. Call option should be positive because the slope will be positive for call option and slope will be negative for put option. Meaning that the options value swings $0.6 for every dollar change in portfolio values. That's what delta means. Opposite direction because it's negative, right? So suppose the stock portfolio falls in value by 2%, the profit of hypothetical protective put. So protective put is, as you know, the stock plus put option, right? So protective put is stock plus put. Let's say the stock value dropped by 2%, which means you lose 2% value out of 100 million, so 2 million loss, right? But you also gain from the put option because you exercise this put option, right? So your gain is 0.6 because the option value changed the $0.6 and $2 million. So 1.2 million, which means you only lose $0.8 million. So that's protective put. Now, without having put option, we can actually create a synthetic option position, which means like the option position without the option. What we can do is we can simply sell in the proportion of the share equals to the put options delta. So delta of the put option is negative 0.6. So let's say just sell 60% of the share and hold only 40%. It means that you only have now 100 million times 40%, which is 40 million. So your portfolio is 40 million. Now, if we lose 2%, it means you have $40 million and 2% loss, then you lose 800,000, which is same as net loss from the protective put. So this is called the synthetic protective put. If we know the delta of the put option, then we can actually create the synthetic protective put without the put option. The benefit is, first, we do not have to find the exact put option we need because it's very hard. Second, we don't have to pay because to buy put option, we have to pay put premium, right? Without paying premium, we can create this option. So once we have the delta of the put option, then we can create the synthetic protective put without holding put option, which is beneficial. Okay, so that's one usage of delta, of the put option. All right, so chapter 16, the part of chapter 16, very important part is two parts. One, binomial, two, Black-Scholes. So I want you to know how to get the value of the option, call option, especially, with the one interval binomial tree. Second, I want you to know how to get the value of the option with Black-Scholes model, using Black-Scholes model with the access spreadsheet we provided. I don't want just you just to copy and paste. No, I really strongly recommend you create your own spreadsheet so that you can, and then step by step. Third, I mean, just the minor things that put parities, like the synthetic protective put. I mean, just to understand this example will be enough for this class. So that's the end of the chapter 16. Thank you for watching chapter 16, and let's do the final chapter in the next videos.